Objectives of today's lecture will enable you to understand the elimination reactions, in which we are going to study the types of elimination reactions. The first one is E1 unimolecular two-step reaction, and the second is E2 bimolecular one-step reaction. And after that, we are going to compare substitution versus elimination. Students, let us start with elimination reactions and try to understand the definition of elimination reactions. Elimination reactions are also called 1,2 elimination reactions. The definition of elimination reactions is that the chemical reaction in which two groups are eliminated from the adjacent carbon atoms is called elimination reaction. That is also the reason why it is called 1,2 elimination, because two groups are eliminated from adjacent carbon atoms. That is why it is called 1,2 elimination. Since beta hydrogen is necessary for elimination reactions, it is also called beta elimination. Beta hydrogen atom in the alkyl halides is slightly acidic due to the electron withdrawing effect of the halogen. Now students, halogens are electronegative. Therefore, it is going to pull the electronic density towards itself, and the inductive effect will be felt by this whole molecule. Therefore, these hydrogens which are present on the beta carbon are slightly acidic. They can easily be donated. So students, when this beta hydrogen is eliminated, along with this X, two groups from the adjacent carbon atoms will be eliminated. That is why it is called beta elimination reactions or 1,2 elimination reactions. Students, for elimination to take place, it is important that the molecule should possess a beta hydrogen. Now, what is a beta hydrogen? You can see that this carbon atom, which is directly attached to the halogen or the functional group, is called as alpha carbon, and the next carbon will be beta, and if a third carbon is present, it will be called as delta. So students, all the hydrogens that are present on alpha carbon are called alpha hydrogens, and the hydrogens which are attached to the beta carbon are called beta hydrogens. Now in elimination reactions, it is a compulsion that beta hydrogen should be present. Now students, in elimination reactions, the attacking nucleophile can either attack on the alpha carbon atom directly to give a substitution product, or beta hydrogen to give elimination product. Now there are two modes in which the nucleophile can attack on the substrate. Students, pay attention to the first reaction. If the nucleophile is going to attack on the beta hydrogen and make NuH, this bond between carbon and hydrogen will be shifted between these two carbon atoms. Now since the valency of this carbon will increase, therefore it is going to dispatch this X, and the bond between C and X is going to be broken down. This X atom will leave carrying a pair of electron as X negative, giving you an elimination product. This is called elimination product, in which two groups, means the hydrogen and the halogen, have been eliminated in this step from the adjacent carbon atoms. Now students, the second possibility is that the incoming nucleophile will attack directly on the alpha carbon atom, and this CX bond is going to be broken down as a result. You will get a substitution product. This nucleophile is going to replace this nucleophile. That is why it is called a nucleophilic substitution reaction. So there are chances of these two reactions to take place. Students, talking about the chances of these two reactions to take place, it entirely depends upon the nature of the incoming nucleophile. Now, if the incoming nucleophile is a strong base, such as hydroxide ion, alkoxide ion, or amide ion. These are the three examples of strong bases, means they can readily accept a proton. These strong bases cause elimination reaction in preference to substitution. Highly polarizable nucleophiles means they are going to be larger in size, that is why they are polarizable. They are nucleophiles but they are weak bases, means they cannot easily accept a proton, such as I negative, RS negative, etc. They are going to give substitution reactions. So simply we can say, if we have a nucleophile which is a strong base, elimination will be preferred. If we are having a nucleophile which is a weak base, it is going to give substitution reaction in preference. Now students, look at this chemical reaction. We are having sodium ethoxide along with 2-bromopropane. Now students, this carbon is alpha carbon because it is having a bromine atom which is a functional group. The carbon to which the functional group is attached is always the alpha carbon atom. The next carbon to it will be beta, since we are having two carbon atoms which are directly attached, so both of them will be called as beta carbons, and these are beta hydrogens. Now students, since we are having ethoxide OR which is a strong base, so elimination is preferred with respect to substitution in comparison to substitution. Now you can see the products. Substitution product is 21%, whereas elimination product is 79%, because we are having a stronger base. It is going to abstract the beta hydrogen in preference rather than giving you a substitution product. In elimination, what is going to happen? That this O negative is going to abstract a beta hydrogen. That bond will be shifted between these two carbon atoms, and this Br will be eliminated, giving you one propene. Whereas when substitution will be taking place, this O negative is going to attack on the alpha carbon, as we have already discussed, and this Br will be eliminated, giving you substitution reaction. But because of the strong base, beta elimination is more easier, means the beta hydrogen is going to be abstracted. It is more easy because it is a strong base. It is going to abstract the proton readily. That is why the percentage of elimination reaction is great.